be able to record.
Sweet.
Perfect.
Awesome.
Thank you.
All right. And I'm going to record on my phone too. Sweet. Now we're started. All right. We can go. Yes. Okay. So
Love the enthusiasm.
thank you. We are going to start with the question, what do you guys know about candles? So we're just anything you guys know. And I'm just going to write these down so I have a reference of what you guys said. Anything?
They use wax, and the wax like goes down as they burn.
Nice. What else?
There's like a wick in the middle.
Yeah. Doing great so far. What else we know?
You need some sort of like flammable thing, like a lighter or a match to start them. You reminded me to light my candle that I had sitting next to me. It's pumpkin spice.
I was just about to light mine too.
This will be great because we're talking about candles today. So
I love it.
Can we go back to this idea of wax goes down as it burns? How does a candle burn? What do we know about how it burns?
When the wick is lit, it like melts the wax, the fire does. I'm so excited for this. I've always wondered how the wax goes down when you burn a candle.
So the wick melts the wax. And so is the wick the thing that's burning, or is the wax the thing that's burning?
I don't know.
I want to say the wick.
Okay. Sweet. That's totally.
The wick is what's like on fire.
All right. This is a great list. We will revisit this at the end. So now I'm going to show you guys the Discrepant event. And I will not be doing it in person because it's very hard to do in person. So hopefully share screen. Share. Okay, can you guys see my screen?
Yes.
Sweet. Slideshow, play from start. So what our Discrepant event is we'll be using 2 candles, and these are normal candles. There's nothing like trick about them or anything. They're just wax candles. And we'll be I did. This is me in the video. I did this. But what it is the candles are aligned vertically. So they're up and down. And the 2 flames are aligned like on top of each other like this. And so both of the candles are lit. So what's going to happen is there'll be 2 scenarios. One is where I will blow out the top flame, and one is where I will blow out the bottom flame. And we're going to try to make predictions and figure out what ways may the candles interact. And what I mean when I say interact is, will the bottom flame stay lit if the top one's out, or vice versa? Or will both candles be blown out? Or how will the 2 candles interact when one of them is altered in some way? So the first case, and I have this nice other whiteboard behind me. This whiteboard is a predict, observe, explain whiteboard. So we're going to start by making predictions about each of these cases. So the first case is what happens when the top candle is burned out, but the bottom candle is still lit. How will this top flame react? So what ideas do you guys have about how this top flame, or how this top candle being burnt out will interact with this bottom candle?
Its wax might still melt because the heat is rising from the bottom candle.
May melt, heat rising. Great idea. Heat rising. I love this. What else? What do you think will happen after these 2 flames, after this bottom flame is blown, after this top flame is blown out? Do you think the top flame will relight, stay unlit, or nothing will happen?
How close are these candles? Can I ask that?
So they are literally, okay, can you see my video or just my screen? They're like held like this. So they're pretty close. I'd say a couple inches maybe.
Okay. And was that a set distance that you were supposed to hold them at?
No.
Or did you just like make that decision?
I made the decision to hold them this close. It'll make sense after. I'll explain it. Yeah. So they're held a couple inches apart like this. So after I blow out the top candle, how do you think both of these candles will be at the end? What I mean by, oh, sorry, go ahead, Michelle.
It might relight. I don't know. That's why I was asking how close it is, because I think it has to be fairly close for it to relight,
Might relight.
but
Okay.
it might.
These are great predictions. These are great. So now we're going to look at the other case. What about this? What if I blow out the bottom candle? Same prediction process. So what do you think?
I don't think anything would happen to the bottom candle because it's not receiving any heat from down below.
Nothing.
I agree. Like, I don't think the bottom candle is going to relight. I think it's going to stay burnt out.
Won't relight. Not receiving heat. These are great ideas. And I love how you guys are bringing in science concepts like heat rises and looking at how heat interacts. Sweet. So now we are going to watch videos of what actually happens, and we'll watch them twice. So the first time, I just want you to watch it. And the second time, we are going to make observations about what's happening. And these can be observations about anything that's going on in the video. Okay, so here's the top candle. And I had a little trouble with this, so I apologize. So here's the video. For this one, I'm going to blow out the top candle. We're going to try this again. For this one, I'm going to blow out the top candle. You can stop it. Okay, so what did we notice about this video? We're going to watch it one more time, and then we're going to make observations. For this one, I'm going to blow out the top candle. We're going to try this again. For this one, I'm going to blow out the top candle. You can stop it. Oh, stop. Okay, so what are some observations that we had?
The smoke from the top candle starts going up, like rising after you blow it out.
Smoke rises, goes up. Perfect. Is there anything else we noticed? How did the candles end up?
The bottom one stayed lit and the top one was burnt out still.
Bottom lit, top burnt out. So nothing changed. Okay, perfect. Now we're gonna watch the other video. For this one, nope. Here we go. Now here's the other video. So same thing, we're gonna watch it twice and then we're gonna make observations. Okay, you ready? Mm-hmm. For this one, I'm gonna blow out the bottom candle. Whoa! You can stop. Also, I'm very sorry about the commentary. That's my roommate. But yeah, we're gonna watch it one more time and then make observations. Okay, you ready? Mm-hmm. For this one, I'm gonna blow out the bottom candle. Whoa! Okay, so what did we observe in this video?
Very interesting. The bottom candle relit.
Mm-hmm.
Isn't that backwards to what we thought was going to happen?
It also was backwards to what I thought was going to happen too. Okay, what else do we notice? What did we notice about the smoke?
The smoke like went right into the flame of the top candle.
Smoke. Perfect. Into flame. What color was the smoke? Does anyone remember? I can play it again one more time. You can stop. Oh. Okay. You ready? Mm-hmm. For this one, I'm going to blow out the bottom candle. Whoa!
I just love the commentary at the end.
That's a great picture. I paused it on too.
It is.
What color was it?
Just like smoke colored. I don't know. It was like the gray.
Gray white. Perfect.
Yeah.
That was really what I wanted. Gray white. Okay, perfect. So now what we're going to try to do is we are going to use our predictions and our observations to try to make an explanation for why this is occurring. But before we get to why this is occurring, what I want you guys to know is that the focus of our lesson is actually on this process called combustion. And so what combustion is it is when oxygen gas reacts with some type of fuel, and that produces fire. And it also produces heat and light, which is fire. So what I really want you to focus on is combustion is caused by some type of fuel plus oxygen gas. So we are going to try to be figuring out what is that type of fuel that's causing this combustion process to occur. So this is going to be the tricky part. So I just want you to know there are no right answers, no wrong answers. We are going to just try to come up with an explanation for what may be happening as to why the bottom candle, when it's blown out, it relights. So do you guys have any ideas? Again, this
it could be like the smoke interacting with the flame above it, like the heat with the smoke.
Heat with smoke. Michelle, this is awesome. Such a good idea. Yes, I love it. One more. Let's just go with one more idea. I know these ones are hard to come up with.
Yeah, I was kind of thinking something similar. Like it had to do like with the smoke, because like the smoke went right to the flame of the other candle.
Smoke went to flame. Yes. All right. You guys both are geniuses. Nice job. So I'm going to explain now what's happening. So what's happening is this wick that you have inside of a candle is absorbent. And so it has a whole bunch of liquid wax inside of it. And the liquid wax comes from when you light a candle and the candle burns down and it turns into that liquidy substance. That liquidy substance gets absorbed up into the candle. So that's kind of what, can you see my mouse?
Yeah.
That's kind of what's happening, or what this picture is showing. There's the wick and the wax is getting like absorbed up into here. And so this is wax in a liquid form. When the wax gets heated up by the fire, it turns from a liquid form into a vapor form. And so then you have all these vaporized wax particles. And this vaporized wax is what reacts with the oxygen. So the vaporized wax is the fuel that reacts with the oxygen to create fire, or to create combustion, like we talked about. And so that's what's happening in this picture right here. And when I first heard this, I was very confused, because I'm like, how does the wax change from a liquid to a gas so fast when the match is lit and it's put on the wick? Well, if you notice, when you light a match right away and you like light the candle, the flame is a little bit flickery. And that's because that's at the very beginning process of the chemical reaction. And so once there's this constant process of liquid wax turning into vaporized wax, then the flame, that's when your candle flame becomes consistent and and doesn't become flickery. So that was the part that I was most confused about, but it's actually really interesting. So then what happens is, moving down into this picture, when the candle is blown out, it releases like this smoky white gray substance. And the smoky white gray substance is all these vaporized wax particles that begin to condense again. So they start turning into more of a solid form. And that's why you have this like white, smoky like looking thing. And that's why I had you guys point out the color of the smoke, because it's actually condensed wax particles. And so what happens is, moving over to this picture right here, when the other heat source actually comes in contact with these condensing wax particles, like in this picture right here, it'll reignite and reheat up those condensing wax particles and change them back into this gaseous form that once again reacts with oxygen. And so it'll create combustion. And so these gas wax particles, when they're heated up, they travel all the way back down and find the wick, which has other liquid wax that then changes back, that then heats up the wax in the liquid wax in the wick and turns back into a candle flame, because the process of combustion starts again. So it's a very lighting a candle is actually a whole bunch of like chemical reaction processes, which I had no idea that they existed before. So that's what we're looking at. So what I would like you guys to do is, I know that was a lot, and I know that was me explaining to you. So for you guys, I would like you to draw a picture in your science notebook about how you understood what we looked at and what I just explained. So I want your picture to be how a candle works, or to draw something about how a candle works. Does that make sense?
Yes.
Sweet. This is one of my assessment pieces. So if you could do that, that would be great. I will give you a little bit of time.
Do you want us to draw like this whole process, or like?
Nope, you just need to draw how a candle works. That's what I'm more
Okay.
looking at. So you don't need to draw like how the two flames,
Like
and
how it relights.
yeah, you don't need to draw that. I'm more looking for this process of combustion. That's what my learning target looks at.
Kind of a messy drawing with a lot of arrows.
Yeah.
Oh, I am so
And
ready.
I realized I can't draw fire very well. It looks like I drew a tulip on top of a candle.
Okay, I'm gonna also, when I see your drawing, I'm gonna try to take a picture of it. 1 second, I can stop sharing my screen now.
Right.
How do I stop sharing my screen? Stop share. Oh, perfect. Okay, let's go, Michelle. I'm ready.
Get it close to you. Oh, is it gonna show it backwards?
Oh, it looks perfect. Okay, so can you explain to me what's going on?
Yes. So let's see if I can point at this backwards. So I have the candle, and then the wick goes all the way up. And then I drew a little bit of melted wax, like hanging out on top of the hardened wax, and try to draw arrows of that going back into the wick right there. So it's the, is that the sense? So the melted wax is being absorbed back into the wick. And this is my little fire up here. That's like the wick is on fire. And I drew an arrow saying like that's the melted wax vapor that's burning in the wick. That's like keeping the fire going.
That looks amazing. Great job.
Thank you. Thank you.
I kind of did like the same thing.
Okay, wait, I'm gonna get a picture
I
of
drew
this
like
for my assessment. Perfect. Sorry, continue.
it's a great drawing. But I drew like the little melted wax on the top, and it's going like into the wick, into the flame, and then it's turning into a vapor.
Perfect. Nice job, guys. You both did amazing. So to finish up, I do not know how much time we have left because we are well past 15 minutes, and we're probably at around 20 minutes now. We are going to look at some of the original ideas that we had about candles and try to explain what's going on. So going back to this board, the wax goes down as it burns. That was our first one. So the reason the wax goes down as it burns is because the wax is melting and getting absorbed up. If the wick was the thing that was burning and we lit the wick on fire, the wick would just burn down right away and we wouldn't have a candle. Like it would last for probably 5 seconds. So the wax is, this one I really liked. The wax goes down as it burns because this shows that as it changes from a solid to a liquid to eventually a gas, the candle gets shorter because it's burning that wax as the fuel. So great job, guys. You are so smart. You know so much about candles. I also really love the wick, and the wick melts the wax, which is partly true. It's actually mostly true. But I think it was just in a different way than you guys were thinking about it originally. So nice job. And the wick burns. The wick is the thing that's ignited, but the chemical reaction process is actually what's burning to create combustion. So nice job. The last one I want to look at is over on this board. And I'm sorry, I was writing sideways because I was sitting sideways, but you guys brought up this idea of heat rises. And heat rising is absolutely true. Heat does rise. But if we go back to, oh, I should share my screen again. Dang. If we go back to this situation right here, what we needed in order for the candle to relight was we needed that smoky vapor trail to reignite the wax particles. And so when we say heat rises, again, absolutely true. However, the heat is rising from this candle, or the smoke is rising from this candle right here. So as this smoke rises up, there's no way that that smoke can interact with this flame. And so that's why that candle does not relight. Whereas in this case, when you blow out this bottom flame right here, this candle interacts with the heat source that's up here and changes those wax particles back from being a condensed wax back to being a vapor. And so a vaporized wax. And so that's why this candle relights. Does that make sense?
Yeah.
So I just wanted to say you guys did awesome. You literally did everything I wanted you to do. So great work. We are definitely over 15 minutes. So I really got nothing else. That is it. Do you guys have any questions? I'll go with that. Do you have any questions?
I don't think so.
No.
Michelle, did it answer?
Yes, this was really interesting to learn because, like, I don't know, I can move my candle is like really far down there, like we're almost to the end of the wax, and the breaker was about to end. But I've always wondered, I was like, I feel like wax can't just evaporate into air like other things, and so I've always wondered how it works. So it makes sense that it like goes in the wick and then like burns that way.
It's really cool because like when I first got this, I was like, I have no idea what the heck is happening at all.
Yeah.
But it actually works with like all kinds of wax candles. So if you have like birthday candles and like you blow out birthday candles, it works with those too, as long as you get like that smoke vapor trail to like go and like touch the other flame. So it's actually insanely cool. I did it so many times.
I wonder if that's how like trick candles work. Like, you know, the trick candles on birthday cakes that you just can't blow them out.
I know. I think that's how it works too. For my extension activity, I put a link to trick candles. However, I didn't read it because I was because
Nice.
that would be the next step. Explore how trick candles work. So
There you go.
thank you guys very much for participating. You guys were great.
Oh, who's recording now?
I think mine keeps going back and forth.